This is a video of a vignette of a demonstration that was conducted at the Florida NextGen testbed in Daytona Beach, which began on September 17, 2014. It included international partners, aviation industry representatives, academics, and observers conducting demonstrations exhibiting various use cases via the Mini Global Enterprise Messaging Service in the international and national airspace systems. This scenario demonstrates the exchange of flight and weather information between air navigation service providers using the FIXM and WIXM data exchange models and the Enterprise Service Bus, or ESB technology, for a flight plan from Ottawa to New York. NAV Canada's primary flight data processor, the Canadian Automated Air Traffic System, or CATS, submits a flight plan to the NAV Canada ESB, which in turn translates the flight plan to FIXM format and publishes it to the Mini Global EMS. Trajectory Evaluator assesses the FIXM flight plan for evaluation. NAV Canada publishes METAR data into the Mini Global network. NAV Canada determines whether the METAR data will require them to update the flight plan of NVC1. The flight plan is submitted. Next, the updated SPECI weather data is sent to Ottawa Airport, indicating a reduction of visibility to 2 miles. The Tech Center and Mini Global Viewer receives the SPECI data. Ottawa experiences delay due to the reduced visibility, and a delay message is submitted. The delay message and the departure message are submitted upon notification from the FAA. This scenario demonstrated the project called AATS, Aircraft Access to SWIM. In this demonstration, the weather information was sent to the aircraft and the flight plan was amended to divert the flight to an alternate airport. The AATS box represents the November 47 aircraft. SIGMET data is injected, which is received on the Trajectory Evaluator. The Trajectory Evaluator received the SIGMET data. In the aircraft, the SIGMET data is accepted. Based on the SIGMET report, NAV Canada submitted the updated current plan. The flight plan amendment is injected for November 47 to divert to an alternate airport. This scenario demonstrates the exchange of flight data information between Harris and Indra Enterprise Messaging System, or EMS to EMS, for interoceanic flights using FIXM 2.0. During the early stages of a flight's life, the FIXM 2.0 flight object is created and submitted by Harris EMS to Indra EMS. The flight information, flight route, arrival, and departure FIXM message has been received on the Harris Mini Global Viewer. Indra receives a series of 3 messages that serves as an indication that the FAA data has been accepted. At this point, the flight starts to move across the New York Oceanic Flight Information Region. An extension of FIXM 2.0 is used to share the trajectory information. Indra EMS receives these messages, processes them, and responds with the complete vision of the trajectory and updated arrival information. Harris EMS provides trajectory updates that give the latest information available of the flight. The amended flight plan is submitted to Aircraft ID. Delta Collaborative Flight Planning Management, or CFPM, submits fleet priority change from a low of 5 to a high of 1. Fleet priority is received by Time-Based Flow Management, or TBFM. TBFM resequences Delta flights, positioning the high-priority Delta flights in front of the lower-priority Delta flights. Delta CFPM submits a fleet priority change. The fleet priority change is received by TBFM. TBFM resequences Delta flights, positioning the lower priority Delta flight behind the higher priority Delta flights. In this scenario, the partner agency submits flight plans to create the initial flight object. Periodic flight object updates are provided while in en route airspace. The flight plan is submitted that diverts to Orlando due to an emergency on board the aircraft. The amended flight plan diverting to Orlando is published to be viewed on the Tech Center Mini Global Viewer and the Surface Decision Support System, or SDSS, display. A partner agency operator enters dangerous goods data for a flight. The color on the SDSS display shows the presence of dangerous goods.
Working together to help shape the future of aviation.